Alright, in this video, I'm going to show you how to multiply radicals. If you forgot how to simplify radicals, I would suggest that you look at the video by clicking on the icon on the bottom right here, so that way you can review how to simplify the radicals, because that's going to be a prerequisite for working on these problems. So again, review it if you don't know how to do it, but if you know how to simplify radicals, then you can move forward with this lesson. So the first thing I want to look at is when you're multiplying radicals. So let's say I have the square root of some number times the square root of another number. Well, I can combine those two under the same square root. And basically your final result is going to be whatever these two multiply out to be. So for instance, so this is more a general example, so it applies to all numbers. So I'll give you a more specific example. So if I had the product of two numbers, so let me say I had the square root of 2 times the square root of 3. So these are my two numbers that represent A and B. So I can multiply them together under the same square root. And here we get the square root of 2 times 3. And if I multiply these two together, I'll get the square root of 6. And then, make sure that your final product is simplified in the very end. So that's when you multiply the square roots. Sometimes you might have two square roots where you have another number on the outside. So what I mean by that, so in general, so I have some number, I'll represent it by the letter C, and it's multiplied by two square roots. So similar to the first example, except here we have another number that we're not taking the square root of, and we're multiplying it with the other two square roots. Well, it's basically the same idea as before. It's going to be C times the square root. Since both of these are under the square roots, I can combine them together. So we get square root of A times square root of A times B. And the final answer would just be C square root of AB. So basically whatever this multiplies out to be, that's going to be our final answer. And usually in a final format, you don't usually write the product there. If you don't see it here, we know that that's what it implies, that we're multiplying these together. So for a more specific example, let's say I had a number like 4 times the square root of 3 times the square root of 7. So 4, you can see here, represents the value for C. My A is represented by 3, and the other number B is represented by 7. So I would take my 4 and I multiply it with these two. So since these are under the same square roots, or they're not under the same square roots, but since we're multiplying them and they're in the square roots, I can combine them together under the same square root, those products. And then we get 4 times the square root of 21. And you can see here I ended up adding this, but you can leave your final answer like that, so it reminds you that we're multiplying out, or you can do it like this, 4 square root of 21. So these two right here represent the same answer. Nothing really different. As a matter of fact, all of these are pretty much the same answers, except that we're just simplifying it. Think of it as like making it into like a cleaner version of what it actually is. So that's multiplying, two numbers. That's one of the things. And then now, if you have another number on the outside, you're just multiplying that out. Alright, so let's move on to another example. So let's say that we have, so let me divide this up so we clean it up. So we have one number times a square root, and then I have another number times another square root. So basically 4 numbers are multiplied together, where 2 of them happen to be within the square roots. One of the things I like to do here is rearrange the order. So as a side note, if I multiply 2 numbers, well, the order doesn't matter in which I switch it out. So that's actually called the commutative property. So commutative property, that's for multiplication. And with commutative property multiplication, that allows you to change the order in which you multiply. So what do we mean by this? So for instance, if I had like 2 times 3, I know that product is equal to 6. Well, if I switch the order, 3 times 2, that's still going to give me the same answer. So the commutative property for multiplication allows us to switch the order. So I'm going to use this property in this problem here. So in this problem here, I'm going to take the square roots and put those next to each other, and I'm going to put the two numbers that are not within the square root next to each other as well. So I'm going to rearrange it so it's C times D times the square root of A times the square root of B. So you can see here that it like cleans it up a little bit. I like to do this. And then I can multiply C times D, so whatever that product is, and that's going to be multiplied with these two. So since these are within the same square roots, I can do A times B, and then my final answer would be CD square root of AB. So again, you can go from this step here, once you're comfortable enough, you can go from this step and then go straight to this step if you want, if you're comfortable enough. But this is more for organization, to make sure that things don't get misrepresented. So if it helps you, go through this extra step here, and then you can get to this step, without making any mistakes. So sometimes it helps in the beginning to do it this way. So now let me give you a more specific example. So here, let me make up some numbers here. So we do like 3 times square root of 4 times 6 times the square root of 5. So you can see here, C is represented by 3, A is represented by 4, D is represented by 6, and B is represented by 5. So I'm going to do the same thing I did over here. I'm going to take the numbers that are not in the square root and put them next to each other. So it's 3 times 6, and then times the other two numbers that are in the square root. So square root of 4, square root of 5. And I can see here that the product of 3 times 6 gives me 18, times, I could combine these together in the same square root, so 4 times 5, and if I take the next step, it'd be 18 times the square root of 20. And if I can see here, I noticed that I didn't catch it. They got me off guard. But the square root of 4, I could have simplified this in the beginning. I could have taken the square root of that, and it would have been just 2. So it could have saved me some time, but since I didn't catch it, I'll just, rearrange it here. I'll go back actually. So let's do this. I know 4 is a perfect square, and 4 goes into 25 times. So you can see I'm doing extra steps because I didn't catch it in the beginning. But I get square root of 4 times square root of 5. So we get 18 times 2 times square root of 5, which gives me 36 times the square root of 5. So that's my final answer, and it's simplified already. So I know I finished with the job. So basically, all these extra steps, I could have avoided it if I would have just simply simplified that here in the beginning. So let me do that so you can see the difference it would have made if I would have caught that earlier. So I would have did 3 times square root of 4, so I'm going to rewrite it, times 6 times square root of 5. So I could have did 3 times square root of 4, I know it's 2. So we get 6 square root of 5, and if I multiply these together, 3 times 2 is 6, and 6 times 6 is 36 square root of 5. So you can see that it took me a couple of steps to answer this problem, and since I didn't catch it in the beginning, I'd have to do all these extra steps over here. So even if you don't catch it, it's okay, as long as you make sure that in the very end you simplify the final answer, make sure there's no perfect squares that goes into that radicand, and then you just you're all set. So let's move on to the next part. So the other example that I wanted to look at is, we'll do one more where you had to simplify that. So let's do something like 3 times the square root of, let's do 2 times 7 times the square root of, let's do 6. So now I'm going to rearrange this. So I'm going to do 3 times 7 times the square root of 2 times the square root of 6. Then I get here 21 times the square root of, I can combine these together and I get 12. And now when I look at this, I know that 12, I can simplify this. So the perfect square that goes into 12 would be 4. So I can split that up as to 4 times 3. And then I'm going to split up the radical. So it'll be 4 square root of 3. So I split these up. and then we get 21 times square root of 4, I know is 2, and I bring down my square root of 3, and 21 times 2, we get 42 times the square root of 3, or you could just rewrite it as 42 square root of 3 without showing that multiplication sign. I can see 3 is already simplified, there's no perfect square that goes into that, so this will be my final answer. And then I'll do one more example, and we could make it into, let's say, 7 square root of 6 times, let's do 2 times the square root of, let's put here, make it 8, and I'll put times 3, so an extra number. So it doesn't really matter what example you get, you just use the same ideas. Any of the numbers that are not in the square roots, I can multiply those together first. So I can do 7 times 2 times 3, and then I'm going to put the square roots next to each other, so 6 times 8, and here I get combined, I can multiply all these together. I get 7 times 2 times 3, which gives me 42. Right, 2 times 3 is 6, and 6 times 7 I get 42. And then I can multiply these together under the same square root. So we get 42 times the square root of 48. And 48, I know there's a perfect square that goes into that one. And the biggest perfect square that goes into 48 would be 16. So I'm going to split that up as 16 times 3. 16 times 3 is 48, so I'm just rewriting that. And then now I can split it up. 16 and 3, it's the separate square roots. And then simplify. 42 times square root of 16 is 4. And the square root of 3 remains the same. There's no, you can't simplify that anymore. And now we can multiply 42 times 4, which will give me 168, and then the square root of 3. So here you have some examples of how to multiply radicals. And in this case, all the radicals we were working with were square roots.